The challenges, so data availability, so being able to model this stuff is really hard. I would say I would never advocate that what we're trying to do here is represent a single dynamic cascade within the system. We are not trying to say that if you have this, if you gave me a system and I did an n-2, that this is precisely how the cascade would happen. There's too many things that we're ignoring, right? We're ignoring all the voltage stuff. We're not looking at hidden failures in protection mechanisms. We're not looking at human interactions and choices they're making. We're not trying to replicate a precise event. We're trying to build a kind of representative case of what would happen if 1,000 of these things happened in your system. So precise event sequencing is like essentially impossible, I would probably argue. Very challenging. This is why whenever there's a blackout, it takes like a team of whatever, 20 engineers, 6 months to then write a report on what actually happened with that. Like it's a huge amount of work to go back in and find out what's happening in the system. So what it is useful is this kind of aggregated risk quantification. So you're trying to find the probabilities. Trying to find the probabilities of risks within the system, and then see how those are affected. Are we all good?
Any question from the audience? All right.
Okay, no problem. Yeah, and then we can use that to then compare statistical things. So it allows us to make some kind of choices to make interventions in the system and then see what effect that has.